No
So
worries.
it's a great pleasure and an honor to be chair of this keynote lecture given by Áureo Paula. Áureo is a longtime friend of mine, a very good one, and a great economist and econometrician. Uh, I usually say that Áureo is to me what Newton Santos was for football, an encyclopedia in economics, given his knowledge about many topics from economic theory to asymptotic theory and many applications in development, health, labor, and so on. So it's a great pleasure to have Áureo, who is professor at UCL, did his PhD at Princeton, then was assistant and associate professor at Penn, and he has been in London for going to be 10 years next year, right, Áureo? Yeah.
Correct.
So Áureo, the floor is yours. We're going to have until 2:30, right? And as I said, if you could speak by 75 minutes, you can open to questions, and we're going to leave like the 5 last minutes for those who have written questions so I can read them. Okay? Thank you once again, Áureo, the floor is yours.
Wonderful. Thank you. Thank you, Sergio. Let me just try and share my screen while I also thank Sergio for the wonderful words introducing me. As he said, we've been friends for a long time, and I'm a great admirer of Sergio's work and of him personally. So it's really an honor for me to be introduced by him. Let me also thank the organizers for this event, for inviting me. It's certainly extremely flattering to be a speaker at these meetings, which I've been to repeatedly throughout the years. So let me just start then to talk about what you're really here for, which is to hear me talk about work that I've been involved in recently. I'm going to start with the protocolar caveats and observations. This work is joint with a huge team of collaborators. One of them is Pedro Carneiro, who is my colleague here at UCL, Barbara Flores, who is in Chile, Emanuela Galasso from the World Bank, Rita Ginja, who is in Norway, and Lucy Craftman, who is in the Institute for Fiscal Studies here in London. This project and what I'm going to tell you about is on social program participation using Chilean data, and particularly focused on spillovers. And what I mean by spillovers here is whether my taking up a social program induces peers of mine, which are going to be defined here as geographic neighbors, to also take up the program. So before I get into the nuts and bolts of this project, let me also say that this is very much ongoing work. So I opted to give something that was still in progress, mostly because it's more exciting for me and hopefully more exciting for you as well. So I'm going to apologize for the tentative nature of some of the things I'm going to say here, but I think there are various interesting things, both substantively and methodologically, to take away, and I'm happy to answer questions on this. And even if you want to email me later on about aspects of this, please do so. It's the right moment for us to gather feedback and to also investigate the applicability of some of the ideas here elsewhere, possibly Brazil, hopefully. So let me then jump right in. As you may know from the Brazilian context, but also worldwide, social program participation is well below its eligibility rates in most countries, be those developed or developing. And the literature has identified several potential causes for that. It's been mentioned that some programs may carry some stigma. There may be an awareness of lack of information about the program itself. There could be monetary or non-material costs, such as the complexity of the application process also. And these are a couple of references that touch upon the many explanations for this less than 100% eligibility take up. There are others. So in this project, as I mentioned, what we are interested in is to what extent does the participation of a peer induce individual take-up in a particular context, as I mentioned before. And what is very interesting in this particular context is that we are going to have a very, very simple model of peer effects and social interactions, perhaps too simple, and I will put my finger on what I think are the more stark inadequacies of what we're doing. But even this very simple model has several difficulties in identifying what actually is the influence of a peer on another peer and disentangling what is, my taking up the program affecting the take up of my peer, or the environment or common shocks that may drive a group of peers to sign up for a program. So to get around this problem, we're actually going to leverage a regression discontinuity design. So what we are going to do is to bring together a social interactions model with an RDD to bypass the difficulties in the spillover models that you may have seen before. But I'll have an overview and indicate what are the major aspects to watch for. So that's what is to come. I am going to focus on a particular program in Chile, which is called Subsídio Único Familiar. So as we all know, Chile is a relatively advanced country in Latin America in terms of social policy. And Subsídio Único Familiar has been around in Chile since the early 80s, if not late 70s. I think it was instituted in 79. And it's a conditional cash transfer program like the ones we are by now very, very used to. And I'm going to give you more details on that in a minute. Okay, so now, even then, the take-up for Subsídio Único Familiar was far from being complete. And what the Chilean government did in the early 2000s, 2001, 2002, was to institute another program, which actually put together a few other independent programs that were already in place before that. And this program is called Chile Solidario. So I'm going to be talking about two programs here. What we are ultimately interested in is this Subsídio Único Familiar, and I'm going to refer to it occasionally as SUF for short. And this ancillary program called Chile Solidario. What Chile Solidario did was to send social workers to the households of very, very poor individuals, even poorer than the ones that were eligible to Subsídio Único Familiar. And these social workers would work with them in various dimensions: psychosocial assistance, helping them out, improve in terms of employment, but also, and crucially, helping them navigate the social welfare system in Chile. So they would identify, well, you're eligible for this particular program. So let's see what we can do to get you preferential access to that program. Now, there are evaluations of this program in Chile. There are several. What they typically find is sometimes a positive effect, sometimes a negative effect in this or that variable. They tend not to be very high, except for participation in Subsídio Único Familiar, which is this conditional cash transfer that, as I mentioned, is the center of our investigation here. And in particular, my co-authors, Pedro, Emanuela, and Rita, have a recent paper that came out in the Economic Journal, where they exploit the eligibility rules for Chile Solidario. I already gave you a clue that I'm going to be using an RDD here. So there is a cutoff rule that you know, if you're below that cutoff, you're more likely to take up Chile Solidario, and if you're above, you're more likely to be ineligible. So they exploiting that cutoff rule, they find that the Chile Solidario program increases the take-up of SUF by 11 to 17 percentage points. And the difference here is, it depends on, they essentially look at my taking up SUF, excuse me, Chile Solidario today, and the take-up of SUF 2 or 4 years down the road. So 11 percentage points is 2 years, and 17 is 4 years. Okay. And this again is from a baseline of about 50, 60%, depending on what sources you get the eligibility and take-up numbers from. But they're certainly not 100% to begin with. Now, our project here builds on this initial paper and inquires, well, you know, can we take this effect of Chile Solidario on the take-up of Subsidio Único Familiar and disentangle what is the direct effect of Chile Solidario from peer effects, which will amplify the effect of the social workers in getting these people to sign up. So if there are peer effects, then the direct effect will be smaller than these 11 to 17 percentage points. And there is some room to exploit these amplification and better match and use resources in allocating, say, social workers to families. We also have a lot of information on the social workers, which I'm not going to be discussing here today, but our plan is to take the outcome of this project here and put together with a study on the value added of social workers, much like you see in the education literature with teachers, and then try and devise the better schemes to match social workers and families in need. Now, as I said, if there are spillovers, we can probably use that to better design the program and better use the resources available to the agency in charge. So that is the grand objective of this project. Again, I'm going to focus here on what we have been doing on trying to dissect these direct and indirect effects. And what I hope to do for the talk today is hopefully to give you more on the context and the data. The data is quite impressive in many respects, is not perfect by any means. Then I'm going to spend some time talking about the econometric challenges that we face and the strategy that we pursue to get around those challenges. I'm an applied econometrician in the end of the day, so I have to talk a little bit about econometrics, but the econometrics per se is not particularly esoteric. And then I hope to give you some preliminary results, and I'll finish by telling you where we're heading with this. My hope is that you will salivate enough that once the paper comes out, you'll be incentivized to read the whole thing. So a couple more details on SUF, the Subsidio Único Familiar program that I referred to. As I said, is a conditional cash transfer program. It's mostly targeted at families with children or children under the age of 18. It is means tested, and it is essentially tested against the score that individuals have on a socioeconomic index that is constructed out of a 2-page form called Ficha CAS. CAS stands for Comités de Assistência Social, which existed until 2007, and then they changed the instrument to another form called Ficha de Protección Social. We here are going to focus only on results from 2002 to 2006. There are a lot of things that happen around this change between CAS and FPS. Among one of them was a very large increase in the benefit. So we're going to focus only on the initial part of the data, which is from 2002 to 2006. Okay, so what happens is this 2-page form is filled in, and out of this 2-page form, the authorities take 13 variables and construct this index, which, if I remember correctly, is somewhere between 350 and 770 points. It's constructed to have an average of about 500, and the eligibility both to SUF and to Chile Solidario is then based on that. But to be eligible to this conditional cash transfer, you have to have a registry in this Ficha CAS. And this is going to be one of our data sources. So we have the universe of people that are registered for this program. And if you ever had an encounter with the social welfare system in Chile, you will have a registry of Ficha CAS. This is renewed every 2 years, if not sooner, if the family wants to do that. And again, is one of the eligibility requirements. Again, you have to have an income that's sufficiently low. It doesn't need to be formal income. And in particular, if you have formal income, the odds are that you're going to be eligible to another program, which is called Asignación Familiar, which is very similar to Subsídio Único Familiar, but it is essentially a contributory family allowance. One of the problems with our data is that we do not see whether you are eligible for the contributory family allowance. So our eligibility markers here will essentially record first whether you have a Ficha CAS, because you have those data, and whether you have essentially an income that's low enough. Okay, so in a sense, we are going to have an eligibility marker that overestimates the eligibility, and my co-authors call this categorically eligible. Now, the application for this conditional cash transfer is done at the municipality offices, and the municipalities are the administrative units that actually run the program itself. And then again, in 2000, if you take data from a survey called CASEN, the participation rate among eligible families was of about 60%. Now, the ancillary program I was alluding to, this Chile Solidario, was launched much later in 2002. Nowadays, it has been encompassed by another program called Ingresso Ético Familiar. So if you go to Chile these days, that's the program you will probably read about, not Chile Solidario any longer. But in the 2000s, that was the first 10 years or so of the 2000s, Chile Solidario was what Ingresso Ético Familiar nowadays does. Now, the Subsídio Único Familiar, it not officially until 2007, but until then essentially targeted the 40% poor individuals in the income distribution in Chile. And Chile Solidario is geared towards even poorer individuals in the lower 5% of the distribution. Okay, so we're talking here about individuals that will, by income eligibility and presence in CAS, be eligible to SUF. And most likely will not have eligibility to Asignación Familiar because they will not be in the Social Security angle. So again, the overestimation is likely not to be that severe. Now, there is an interesting thing in the way the program was implemented, which was that eligibility was based on a municipality and period-specific cutoff, above which, you know, very few people will have received the social worker from Chile Solidario. So what did happen was that the government initially launched the program aiming at a particular percentile of the population. But as in many other countries we know in the world, the resources were not sufficient. So what happened was that they tried to enlist all the individuals that were eligible to Chile Solidario up until the cutoff that they were able to afford with the funds that they were given. So if initially they were hoping to assist more than 200,000 families, they were only able to phase in the program at installments of 50,000 per year, for example. So what would happen is that the municipality would receive the funds. It would essentially try to aim at the poorest individuals that were eligible to Chile Solidario up until a threshold. So the official threshold that, you know, would have, addressed say the originally 5% lowest in the income distribution was higher than the effective cutoff that the municipalities were able to cope with. So what my co-authors do in this 2019 paper on which we build is that they actually estimate the effective cutoffs that were potentially used by the municipalities. And the way this is done, as has been done in other papers in applied microeconomics, like this paper by Che and co-authors and David Card and co-authors, is to use structural braid techniques from the time series literature, and in particular, this paper by Bruce Hansen in 2000. Now, so this is how this looks. These are municipalities around Santiago de Chile. Okay, so let me just focus on the upper panel here. And what you have in the y-axis is essentially the proportion of people, say, at this particular CAS level. This is the CAS score, the score that's constructed with this two-page form, that are in Chile Solidario. So as you can see that in El Monte, you see here a non-zero proportion of the individuals at these lower CAS scores that are participating in Chile Solidario. And then once you cross a particular level, it goes down to 0. Now, the dashed line is the official cutoff. And as you can see, El Monte didn't have the resources to go all the way up to that official cutoff. The solid line is the effective cutoff that's estimated using the techniques that I mentioned before. And those techniques are simply, I take a probability of being in Chile Solidario before the takeoff, a probability above. I stipulate several candidate cutoffs, and I look at the cutoff that maximizes the R-squared. So in a nutshell, this is what the Hansen 2000 paper advocates doing. And you can see that it works pretty well for El Monte, San Miguel, Calera de Tango. Now, if we go to the lower panel, you see that, this algorithm will spit out a particular threshold, even if visually there's not much going on. And sometimes we'll even put it slightly above the official cutoff. Now, if you know Santiago, you may recognize some of these municipalities. Las Condes is a relatively wealthy neighborhood in metropolitan Santiago. So again, not only the municipalities faced restrictions with respect to the amount of money they could distribute, but also to the number of social workers they could deploy. So for more remote and possibly wealthier neighborhoods, the program was not prioritized. So as you can see, very few people that would have been potentially eligible are actually part of the program. Again, here we're placing the cutoff above the official one. As you can see, there's nothing going on. Lo Barnechea is a relatively remote and mountainous neighborhood in Chile, and as you can imagine, it's more expensive to send the social workers there. Now, what we do in our analysis is we're going to keep these municipalities. If anything, they are going to attenuate the results that we encounter. So if you remove them, the results get even stronger. The reason why we are not going to remove them, if you start thinking about this as a two-stage least squares story, where I have y as a function of x and an error, and then I have x being endogenous as a function of z and another error. Say the reduced form is going to be y as a function of z and an observed error. If I now take out the municipalities where I don't see much of a discontinuity, it's a lot like my restricting my sample based on the outcome. And this is not something that we would like to do, because this is going to induce all sorts of econometric issues. One of the things that we haven't yet done, but we are in the process of doing, what this would entail in this two-stage least square setting is to weaken the first stage, okay? So even though if you put them all together are F statistics, and all the statistics that you would be interested in are high enough, I think the F statistics is around 500, which is way, way above the values in the recent paper by Marcelo Moreira and co-authors of 104, if you've seen that paper. We are also planning on using recent methods in RDD that look at weak IV robust estimators like Henderson and Rubin in this context by authors like Chris Roth and and co-authors. But what we're doing here is more elementary than that, and we are keeping these municipalities for now. Now, this is data not that we are using, but from a separate survey in Chile. And it's interesting because it talks about awareness about this conditional cash transfer. So if we focus here on the first column, about a third of the individuals that were surveyed here were aware of the program. A fraction of those would claim to know the amount or know the correct amount. And even then, they would not know the exact eligibility criteria in full. And even a lower fraction of those would have applied. So this seems to indicate that awareness is probably one of the main conduits for the low take-up. And this is, I'll let you know later, is one of the things that we do seem to encounter there. Now, when they know, how do they learn about this? And this again borrows from another different paper by Claret in the early 2000s, where a lot of people would have learned about it either through publicitary campaigns or by a social worker, but a non-significant amount of those people, number of those people would have learned that from friends and neighbors. And this is the type of phenomenon that will give us a spillover that we are after here, okay? This is just to motivate where we're heading. Now, this is the first page of the Ficha CAS, which was the instrument in place before 2007. It will essentially gather information about asset ownership, income, education, occupation of all members in the household. As I said, a few variables out of these are plucked out of the instrument to construct the socioeconomic index. And we do have access to the registry itself, which is linked to information from these social programs via the ID of those individuals. We also use data from the Ministry of Education from 2000 to 2006. And the reason why we use this is because, again, the take-up or participation in SUF is contingent on sending your kids to school from the age of 6. We also have data from the municipalities on office locations, because you have to apply to SUF at the municipality office. So we use this as a proxy for, application cost. Whereas the first one, the school information, is used as a proxy for compliance cost with the program. Well, it turns out that from the age of 4 to 13, school attendance in Chile is almost universal. So there's, little, if anything, in terms of school attendance or compliance before the age of 13. When kids get to high school, that's when things get to the 70% or something like that. Now, in our regressions here in this presentation, I'm only going to be using data from 2003. Why? Because the program starts in 2002, and I'm going to measure whether they take SUF 1 year later, just to give them a little bit of a slack there, up until 2007, which is when this new instrument gets into place. We also have a lot of geographic information, by the way. Okay, so what we did is we took these data from CAS and we geocoded everything. It took us many months to do that. We essentially, but not exclusively, use Google Maps. Even Google doesn't have all the maps you would imagine. So if you go to a favela in Rio, you will, Google is not going to be super helpful there. It's the same thing when you look at more remote areas in Chile. So we are, as expected, more successful in urban areas and less successful in rural areas, where our success rate was only up to 30% in one of the years. Now, if you think about it, this introduces an interesting selection problem, because the people that we are more interested in are exactly the poorer ones, which will be the hardest ones to identify geographically. So for this reason, although this is a very interesting problem, hopefully we'll be able to solve it in another paper. What we're going to do is to focus on the Santiago metropolitan region, where we have almost perfect success in recovering the geolocation of the individuals in the Ficha CAS. Okay, and we are hopefully doing that in other major metropolitan areas in Chile as well, like Valparaiso, later on. So once again, we focus on Santiago. And eventually what we are going to be able to do is to look at neighbors defined by everybody that's within a particular radius of me. So if I'm living within 50 meters of Sergio's, I'm a neighbor of his, and then there may be someone that's living within 50 meters of me, but not within 50 meters of Sergio, who is a neighbor of myself, but not a neighbor of Sergio. So we're going to have these overlapping neighborhoods, which, you know, make sense to begin with, but also are helpful in circumventing some of the difficulties that show up in the econometric models trying to get at spillovers. Now, for this presentation, and there are reasons for why we do that to begin with, I am going to focus on a very particular notion of neighborhood, people that live in the same apartment building. So I'm going to be focusing only on CAS participants that live in a multi-family building, and everybody in the building is a neighbor of everybody else. So it's a particular neighborhood structure. So if you think about networks, it's a complete network that it has its own difficulties, but it has its advantages because it's going to allow me to get a lot of expressions in closed form, which we wanted to essentially use as, you know, a proof of concept to what we're doing here and visualize better what's going on. So this is a map of the Greater Santiago area. Here, this is using our measure of eligibility, which is, again, overestimated. So the take-up rate is going to be likely underestimated. But you can see that there are some areas which are in darker colors that have a higher take-up, San Jose de Maipo, and other areas that have lower take-up. Remember Las Condes, the wealthy neighborhood. So here it is, Las Condes, and Lo Barnechea, which is another area with very low take-up. But what you can see here is some clustering of whether on where you have more or less take-up of SUF. Of course, this could all be related to the way individuals of a particular socioeconomic makeup are located in the space. So one thing that we can also do is to run quote unquote spatial regressions where we control for their socioeconomic status. And in these regressions here, for example, we are controlling for the CAS score and indicators of demographics such as whether the household is headed by a man, for example. Now, if I do that, and then I look at whether I take up subsidio único familiar against the take-up of my neighbors, as you can see here, if I go from 0 to 50 meter radius, and then look at the donut that comes after that, 50 to 71 meters, 71 to 87 meters, the correlation goes down, and it's more or less the same across all the years in Santiago here, which is what you would expect if you have this neighbor of neighbor influence. Of course, you know, it could be something else, but at the very least, you want to see a decay in the autoregressive, so to speak, coefficients as we are seeing here. The reason why we have these, you know, 50 meters here, 21 here, and a little bit less here, is that we wanted these donuts to essentially have more or less the same area. So if I had 0 to 50, 50 to 100, 100 to 150, they would have very different areas. So but it doesn't really matter. If you do it in that way, you get something similar. Now, this is all motivational. And hopefully you know more or less the context here. I'm going to give you a little bit more econometrics now. I'm going to start with a very stylized model for what we have. As I said, it's going to be a very simple model. It's the simplest model you can imagine. For this is a system of simultaneous equations. Not only that, it's a system of linear simultaneous equations. So this system is very close to what Chuck Mansky proposed in a very well-cited paper in the early 90s. Called the reflection problem, which you may have heard about. And what this econometric framework stipulates is that you have an outcome, say for, in this case, individual one. So if we think about this as this multi-family building, we can think about this as being a building with two flats. So Mr. 1 and Mrs. 2, say, are the residents in these two flats. So we can imagine that in my case here, Y is going to be whether this person is taking up subsidio único familiar. So if Mr. 1 takes up SUF, that may depend on whether Mrs. 2 takes up SUF, characteristics of Mr. 1, And in one particular characteristic that will be important here, or covariate, is whether Mr. 1 is in Chile Solidario, and potentially characteristics of Mrs. 2. Of course, there could be common variables affecting their take-up, something that is germane to the building itself, that's not observed and potentially correlated with the other covariates that are gonna, conflate and confound our inference and identification of the SUF on SUF coefficient. This is what is going to encode and codify the spillovers I'm alluding to, this beta coefficient here. Now, in this paper by Chuck Mansky in 1993 called The Reflection Problem, he essentially indicates a few issues with a specification like that. One is that, well, if you even ignore the common shocks, the W components in each of these equations here, you have a system with two equations, two endogenous variables, and two exogenous variables over here. If this gamma here is not different from 0, to go back to our early classes in econometrics, we have a problem because we don't have an excluded variable. So this simultaneous equation system wouldn't be identified. Okay. There are also issues, of course, with the presence of this common shock here that will again make people in the same building take up SUF or not take up SUF, not because I influence my neighbor and vice versa, but because we are exposed to the same shock. Could be, the social worker or something like that. Okay, so what in the Manskian jargon, and I may refer to this throughout, if you've never heard, this is what I mean. This beta is, again, a social effect, my taking up SUF, leading my neighbor to take up SUF. He calls this the endogenous effect. This gamma can also be seen as a social effect, but is not one that will generate a multiplier. So he distinguishes it by calling it a contextual or exogenous effect. And these are just, common shocks. So he calls this correlated effect. So this is how this literature sometimes refers to these elements here. So what distinguishes the beta and the gamma, as I said, is that the beta will generate a multiplier. So if my X goes up, my Y will go up. Then it's going to affect the Y of my neighbor, which is going to affect me back. So there's this feedback going on. Okay. On the other hand, if my X goes up, this doesn't necessarily affect the X of my neighbor or the Y of my neighbor. So except through the gamma. So before I move on, let me just say that in empirical work, the element that here is most challenging to provide persuasive evidence in favor is that you are not obtaining spurious inference that is conflated by the existence of these common shocks. And this is where the discontinuity is going to help us here. Okay. So there's always this suspicion in the back of the reader when you're talking about a pure effects, paper on whether, is this pure effect or is just a shock to the group. Now, before we get there, let me go back, and incrementally add elements to our econometric specification. So I'm going to go back to the paper at the Econometric Journal by Pedro, Emanuela, and Rita, published last year, where, as I said, what they're doing is they're looking at whether the individual takes up SUF, which is the Y variable here, and how it is affected by Chile Solidario, which is the covariate of interest. So this lambda here is going to be, the effect of Chile Solidario. And you can think about it, if you want to put a story behind it, it's going to be, depending on how effective the social worker is in helping these guys navigate the social welfare system. Of course, whether I participate in Chile Solidario may be correlated with other unobservable features that also induce me to take up SUF. So what they do is to use the cutoff rule to instrument for the participation in Chile Solidario. So this model has no spillovers or social effects. So the beta or the gamma are equal to 0. Okay. And what they are going to be doing is to use the eligibility to Chile Solidario, which is whether your CAS score, which is this variable CAS here, is less than or equal to the particular cutoff that they identify using these structural break methods that I alluded to before, just as you would do in a common conventional RDD design. Now, let me mention a couple of things before I show what they do later on. Now, the fact that the cutoffs are estimated is not going to have an effect to the first order on the estimates that you obtain here, following conventional papers on the literature. So it turns out that you can learn about it fast enough. The convergence rate is sufficiently high that asymptotically it doesn't really affect matters, insofar as there is a positive discontinuity. So you should keep that in mind, because we're not going to adjust for that. But remember that I still have some municipalities that have no discontinuity that can be visible to us. Oh, and before the next slide, let me also mention that I am not going to talk at all about manipulation here, but all the tasks that you could possibly envision on potential manipulation of this program have been performed by Pedro, Emanuela, and Rita in their previous paper. We also redid that with our sample, and we do not find evidence of any. And there are good reasons for there not to be any manipulation. First of all, the cutoff itself is not known. The variables that are used to construct the CAS score are known, but the algorithm is not publicly available. And the forms are actually checked, and a non-trivial proportion whenever an imprecision is found is actually returned. Of course, there could be manipulation at a grander scale. I presented this paper at the Inter-American Development Bank not long ago, and fortuitously, there was one member of the audience whose mom had been a beneficiary in the program. And what this person told me was that, well, what could happen is that the social worker comes and, well, let's take the TV off so that you go down in the scale. But what is very unlikely to happen is that you're able to manipulate right around the cutoff itself, and we don't see any evidence for that. Now, if we introduce the take up by my neighbors, which now are this right-hand side variable, the average take up of SUF of my neighbors, so this is y bar minus I here, I have a slightly more complicated econometric model, okay? Now, and the challenge here is to be able to detect beta 0 and not have it be conflated or misread as a pure effect when indeed it was a common shock. Okay, so again, this is at the core of the Mansky paper in the early 90s. So in our case here, we are able to circumvent this by using the cutoff rules for Chile Solidario, which around the cutoff are going to emulate controlled trial. So you're more or less randomly allocated to Chile Solidario, and that should be orthogonal to these other confounding factors that you may be worried about. But remember that we still had a non-excluded variable problem, even if I didn't have those common shocks. And throughout my presentation here, this is more directly addressed by not having the characteristics of my peers enter whether I take up SUF or not. Okay, there may be reasons where you would like to have, say, the CS of my neighbors affect my taking up SUF, even if they don't take up SUF themselves. So this is something that we want to introduce later on. But even if we introduce that back into the picture, we are still able to identify the model, because in this literature, if you have variation in the group size, which if we're thinking about buildings means we have variation in the building size, the number of flats in the building, or I have those overlapping neighborhoods. I have a neighbor whose neighbor is not necessarily my neighbor. I can identify the model. And the reason why that happens is that I can use my neighbor's neighbor, who is not my neighbor, to generate instrumental variation to address the endogeneity issues. So if I now put that into the picture in the simple model that I had before, I get something that actually is the model that is proposed in a recent paper by Gordon Dow, Catherine Loken, and Magne Mogstad at the EAR in 2014. They're looking at groups of 2 people there. Those are either co-workers or siblings, if I remember correctly. And they're looking at the take-up of a parental leave program. And the discontinuity here is in the timing at which the program was introduced. But you can think about this in a context here as well. So I have a building with 2 people, Mr. 1 and Mrs. 2. Again, the SUF take up by Mrs. 2 may affect Mr. 1 and vice versa. And if I'm receiving the visit from the social worker, I may be more likely to take up SUF. But then again, what I'm not allowing for here is that the CS of my neighbor, Mrs. 1, affects the take up of Mr. 1. And then again, this is the equation that summarizes the cutoff rule. So if I'm below the eligibility cutoff, I'm more likely to take up Chile Solidario. And again, this is the estimated cutoff that we're going to be using here. Now, what I can do in this system, I can take equation 2, substitute that into equation 1. And then if you do that, you get rid of the Y2 variable, whether Mrs. 2 is in SUF or not. And I can express whether Mr. 1 is in subsidio único familiar as a function of him being in Chile Solidario and of Mrs. 1 being in Chile Solidario, and an error that aggregates the errors of the 2 equations above. Now notice the following. If I can estimate the coefficient in front of Mr. 1's Chile Solidario participation and Mrs. 2 Chile Solidario participation, if I divide this parameter, Mrs. 2's parameter, by the parameter for Mr. 1, I get beta. If I get beta, I can then solve for lambda. So if I get these quote-unquote reduced form parameters, I'm home free. And you can do that if these 2 individuals are close to the cutoff, because now I have an instrument for Mr. 1 taking up SUF and for Mrs. 1 taking up, for Mr. 1 taking up Chile Solidario and for Mrs. 2 taking up Chile Solidario, which is their near eligibility or ineligibility around the cutoff. And then I can estimate these parameters consistently and then estimate lambda and beta consistently as well. Now, this works very well if they're both close to the cutoff. But now let's imagine that I get a 3rd individual in the building. So now I'm thinking about a 3-flat building where Mr. 3 is far from the cutoff. So I cannot use this instrumental variation around the cutoff to emulate something like a random assignment to Chile Solidario. Okay, so the equation now is going to become one in which I have the SUF for Mr. 1, Mrs. 2, or Mr. 3, dependent on the average take-up in the building of the other residents in the building, and these individuals Chile Solidario plus an error. Now, Mr. 1 and Mrs. 2 are close to the cutoff, so the natural temptation is to, well, Mr. 3 is far away, let me just ignore this individual, and then throw or relegate the participation in SUF by Mr. 3 to the error term. And this has been done in applied work, but this is problematic. Why is this problematic? Now, if I say increase this variable CS for Mr. 1, what this is going to do, and I can increase this via my instrument, say I make this person eligible. By being eligible, he or she is more likely to take CS. If he or she is more likely to take CS, he or she is more likely to take up subsidio único familiar. But then if individual 1 taking up subsidio único familiar affects the take-up of subsidio único familiar by Mr. 3, Mr. 3 is in the error. So my instrument, which is the eligibility of Mr. 1 here, is no longer orthogonal or uncorrelated with the error. So my IV now is invalid. So you got to be a little bit more careful in pursuing this strategy. So what you can do, though, is to focus on the right moments or the right errors, which is the quote unquote structural error, the epsilons that we have in my system of simultaneous equations, which are given by this expression here for each individual. Now I'm aggregating here in the SUF participation, not only whether my neighbors who are close to the cutoff for eligibility to Chile Solidario, but also whether my neighbors who are potentially far away from that eligibility cutoff, whether they participate in Subsídio Único Familiar. Okay, so here I'm taking everybody in the building, close or far away from the cutoff, and not only those that are close to the cutoff. And then what we can do is that we can explore moment conditions locally to this cutoff of eligibility to Chile Solidario, which is what this expression here means. Near that cutoff, I should expect my near eligibility or ineligibility to Chile Solidario to be orthogonal to the structural error that is affecting my take-up of SUF. And I can do that both for myself and for the eligibility of my neighbors. So essentially what I'm suggesting here is to instrument the average take-up of Subsídio Único Familiar in my building for everybody near or far from the cutoff by the near eligibility or near ineligibility of my neighbors who are close to the cutoff. So what we are ultimately going after is doing generalized method of moments, or GMM, at a discontinuity. So you can see this as a generalization of RDD. Okay, and if I get my way with my co-authors, we're going to call this the disco jam. So you heard it here first. So if I go back to my 3 individual example, where again Mr. 3 is far from the cutoff, whenever I'm looking at Mr. 1 or Mrs. 2 on the left-hand side and the average of the remaining neighbors in the right-hand side, I'm going to be instrumenting this average here, where this individual here, 1 or 2, is close to the cutoff, but individual 3 is far from the cutoff, by the eligibility to CS for either Mr. 1 or Mrs. 2, depending on whether I'm looking at the equation where Mr. 1 or Mrs. 2 appears in the average. Okay. Now, for this to work, for this to be a good IV strategy, I need my eligibility to Chile Solidario to induce me to take Chile Solidario. And I need my participation in Chile Solidario to induce me to take Subsídio Único Familiar. So the strength of my IV is going to be modulated by the first step, which is going from eligibility to Chile Solidario to participation in Chile Solidario, and by a second step where I go from participation in Chile Solidario to taking up SUF. Okay, so you can think about the strength in these two ways. If eligibility doesn't affect my participation in Chile Solidario, then I have no instrument. But even if it does, if Chile Solidario doesn't affect my take-up of SUF, I wouldn't have an instrument because I wouldn't be able to use that to instrument my neighbors' take-up of SUF. Now, what we do in the paper, that I'm not going to get into details here, is that we are using essentially 2 moments. One moment that focuses on the individual and another set of moments that focuses on the neighbors. If you think a little bit about it, it's not hard to imagine that I'll have essentially 3 situations. One situation is that I'm going to have individuals who are close to the cutoff themselves, but have no neighbors close to the cutoff for eligibility. I'm going to have individuals who are not close to the cutoff, but whose neighbors are close to the cutoff. And I'm going to have individuals who are both close to the cutoff and have neighbors close to the cutoff. So if we were to use only individuals that are close to the cutoff and have neighbors close to the cutoff, it turns out that your sample size is going to reduce dramatically. So what we do here is to extend ideas related to 2 sample IV, where I'm running an IV regression of Y on X, instrumenting for Z. And I can do that if I have 2 different samples, one with information on X and Z, and another one with information on Y and Z. I can run these 2 regressions in these 2 samples and then combine them to get my estimate for the effect of X on Y. To these circumstances here, the difference here is that in the 2 sample IV, I have 2 completely unrelated samples. Here, you can think about it as being, 2 moments or 2 samples, but also having an overlap between them. In other words, if I were to go back to my presentation in the 2-sample IV, I have one sample that's going to be informative about this first moment and another sample that's informative about the second moment. In our case, we're going to have a fraction of individuals who are going to be informative about the first moment, another fraction that's going to be informative about the second moment, and a third fraction that's going to be informative about both. So it turns out that in our data, this multiplies the sample size by 3. And as you can imagine, this gives us a lot of precision to our estimates. So I think this would be an interesting thing in other settings as well. Now, one other thing that I can do is to emulate that regression that I have had of Y1 of the SUF take up by Mr. 1 on the Chile Solidario of Mr. 1 and the Chile Solidario of Mrs. 3. So if I have 3 individuals, this equation is going to be represented in this way here. I can translate that into a regression, a quote-unquote reduced form regression like this, where I can express the reduced form coefficients as functions of lambda and beta. And just like I did before, by dividing one coefficient by the other, I can obtain the beta. So in this case, the formula becomes this one here. This is for 3 individuals. And it turns out that we can do that for buildings of larger sizes. Now, why is this interesting? And this is one of the reasons why I'm using buildings, because I can do this manipulation. One advantage of focusing on this particular strategy is that the path from instrument to endogenous variable is more direct, because whereas in the past I was going from eligibility to Chile Solidario to participation in Chile Solidario, and then from participation in Chile Solidario to taking up SUF of my neighbors, here I'm going straight from eligibility to Chile Solidario to whether they participate in Chile Solidario or not. So you can view this intuitively as strengthening my instrumental variables to a certain extent. So in this presentation, I'm going to focus on this. And then again, I can do this inversion in this setting, whereas I wouldn't be able to do it near the overlapping neighborhoods. So this is one of the reasons why we pursued the buildings first. Now, for larger buildings, as I said, you can do the same thing. You can find the mathematics to do that in previous papers like this one by Bramoyer, Jebari, and Fortin, and a recent survey that I have in 2017. So for a building with size NG, the formula that you get would be this one, and then the pi's will be given by this expression here, and you can obtain similar ways of retrieving betas, lambdas, and this constant coefficient alpha from the pi's themselves. Okay, so again, this is the formula for the beta. Now, another interesting thing about focusing on this specification is that there are some interesting testable implications of this model, which is if I look at the coefficient in front of my own participation in Chile Solidario in the previous equation, so pi1 is whether I, individual I, is in Chile Solidario, this should go down with building size. And if I look at the coefficient in front of the individual's neighbors, it should go up in building size. Another thing to verify too is that, well, if there are no spillovers and lambda is constant, remember that lambda here is encoding the social worker, so there is no real reason to imagine that social workers would have an effect that's differential by building size unless they specialize in building sizes, and this is not what we see in the data. Then what happens is that my coefficient for Chile Solidario is constant, and the coefficient for my neighbors is 0. Okay, so you can see this directly already in the data. By the way, this equation where I'm regressing might take in up SUF on whether I am on Chile Solidario and whether my neighbors are on Chile Solidario is sometimes in the literature referred to as the social returns equation. I think that's what Josh Angrist terms this. So once we get the pi, what we need is to find a way to quote unquote solve for beta and lambda, but instead of imposing the restriction directly, which we can do if we're running GMM, what we can do is to use an old paper by Gary Chamberlain, which quote unquote solves the equations in terms of pi's for beta and lambda by minimizing a particular distance from 0 of the several pi's according to building size. So we're going to pursue that. Now, let me tell you a little bit more about why it is that things get hairy or complicated when I go away from buildings. If I encode now who is neighbors of whom in a big matrix for the whole of Santiago, where, you know, if Sergio and I are in Santiago and we are neighbors, I'm going to have a row for myself and a column for Sergio, and I'm going to put a 1 there, or a 1 over the number of neighbors, as sometimes people do in normalizing these matrices. I'm going to have a huge, enormous matrix. Okay, so the strategy here is to essentially look at this very, very large system of simultaneous equations where I'm stacking now in this expression here a vector with all the residents in the greater Santiago, and I'm looking at the SUF participation by those individuals as a function of the SUF participation of their direct neighbors and whether they are in Chile Solidario. If I am to go after the pi's, what actually I'm doing is I'm transferring the y's to the right-hand side and inverting this matrix, identity minus beta A. Now, remember, this is a huge matrix for the whole of Santiago that I'm going to have to invert. So you can imagine that this is really, really not a wise thing to do, even if you have the computational resources. So again, in the 3 people example before, this A matrix was essentially, you know, if I'm individual 1, I'm in row 1, I'm going to put weight 1/2 to Mrs. 2 and weight 1/2 to Mr. 3. And the same thing for the other 2 residents in the building. Okay. Now, we're not going to try to solve this in closed form or go after the pi's, but what you can do is you can expand this in a series. And if you remember this from basic maths, if you 1 over 1 minus alpha, you can write this as 1 plus alpha squared, and so on and so forth. You can do this under certain circumstances, and they are empirically plausible, and express this inverse in terms of an expansion of this neighborhood matrix. Now, if you are familiar with this literature on networks, what this matrix here is doing, as I just told you, is encoding information about who are my direct peers, my neighbors. If I take the second power of this matrix, if you don't know that, I'm telling you now, what it's doing is actually recording who are my neighbors' neighbors. And if I go to power 3, it goes to neighbors of neighbors of neighbors. So this is essentially asking us to regress Y on neighbors, neighbors of neighbors, neighbors of neighbors of neighbors, and so on and so forth. And hopefully, if beta and lambda are sufficiently small, this dies off sufficiently fast that this, if you truncate it at a particular step, you won't have a lot of contamination. So this is another thing that we could do in that case once we get there. But we can always do the GMM where I'm instrumenting the SUF of my neighbors by the eligibility to CS. Remember, the problem there is that I'm going to have a weaker IV instead. Now, in the, I imagine it's like 10 minutes that remain, let me go over a couple of the preliminary results that we have in the data, just to, you know, see, you know, on the ground what we are actually doing. So this is a representation of our data. So we have multi-family buildings, as I told you before. In total, throughout all the years that we have 170,000 individuals. Okay. Here we are focusing on individuals that, you know, are close to the cutoff or have one person close to the cutoff, one neighbor close to the cutoff. They themselves are close to the cutoff, the neighbors are close to the cutoff, or we require them to be close to the cutoff and the neighbors to be close to the cutoff. But what I would like to point out to you, if I were to focus, for example, on individuals that are close to the cutoff for eligibility themselves, and whose neighbors, at least one of those, is close to the cutoff, our sample size would be 23,000. Okay. Now, these are the individuals that have at least one neighbor close to the cutoff. They're more than 23,000 because, you know, some of these guys here are not close to the cutoff themselves. And this column here, the third column, is focusing on observations where the individual, him or herself, is close to the cutoff and may or may not have neighbors close to the cutoff. Again, it's larger than 23. So if I look at observations where either the person is close to the cutoff or the neighbor is close to the cutoff or both, my sample size goes from 23,000 to 77,000. So the increase in sample size is massive. And this is the sample that we're actually going to be using, the 70,000 here. Okay. Now, in the results here, I'm going to focus on buildings of up to 5 families, and these are families that are in CAS. These are not necessarily that the buildings have only 5 flats, but there are 5 families in CAS, in the building. So I'm going to stop here. And we can add for the buildings, they're not very numerous in our data, and they don't really affect our results very much. But just for cleanliness, I'm going to focus only on 2, 3, 4, 5 resident buildings. Now, here's one interesting thing. So I've been telling you that the idea for this cutoff is to emulate a random assignment trial or exercise. So if this is really the case, and I look at people that are close to the cutoff with neighbors that are close to the cutoff, the likelihood of this person being assigned to being nearly eligible or nearly ineligible should be unrelated to whether the neighbors are eligible or not. So what we're doing here is taking people that are close to the cutoff and have neighbors close to the cutoff and regressing their near eligibility or near ineligibility on the near eligibility or near ineligibility of other families that are close to the cutoff in their buildings. And as you can see here, there's no correlation. Okay, so this is kind of nice because it's essentially reaffirming our intention that these guys are as good as randomly assigned to potentially participate in Chile Solidario. Another thing that's interesting to visualize here is that if I look at eligibility rate to Chile Solidario for those individuals that are close to the cutoff locally, where I can emulate this random experiment, and I look at whether they take up Subsídio Único Familiar, as you would expect, buildings with more people eligible to Chile Solidario will have a higher take-up of SUF, because among many things, what these social workers are doing is telling them, well, you can get this nice benefit. Now, I can also look at what happens to the take-up of SUF among people that are eligible to Chile Solidario by eligibility rate in the building, and then again, as you would expect, the take-up goes up for Subsídio Único Familiar. So if you want to think about this as a treatment and non-treatment variable turning on and off, this is essentially, well, if you're treated, you're more likely to take up Subsídio Único Familiar. What is again indicative of there being spillovers is that if I look at the take-up of Subsídio Único Familiar among those individuals that are ineligible, but just by a little because they're close to the cutoff, according to the eligibility rate, the more people are eligible in my building, the more those people that are not receiving the Chile Solidario directly are taking up SUF. So this is again indicative of there being spillovers. And in the treatment effects jargon, what this means is that the stable unit treatment value assignment, SUTVA, doesn't seem to hold here. There is interference. Now, this is reproducing results in Pedro, Emanuela, and Rita's paper in 2019. So no spillovers whatsoever. And it's reproducing this in our data. So remember that in their data that they do for the whole of Chile, they get about 15%. Here we get something much larger. It's 27%. This is like people living in multifamily buildings in Santiago. Okay, so this is the first stage. Whether I participate in Chile Solidario on my eligibility. This is the reduced form or intention to treat. Whether I take SUF 1 year from now and I'm eligible to Chile Solidario this year. Again, this 0.27 is roughly the ratio of column 2 by column 1. And the types of graphs that you would see in papers on RDD also look pretty nice here. Again, if I'm nearly eligible to Chile Solidario, my participation jumps by 0.15. And then again, it also affects my take-up of SUF. Now, if I'm thinking about spillovers, what I want to know is whether my distance from the cutoff affects the take-up of SUF, not of myself, but of my neighbor. And if we look at a graph where I'm plotting now my neighbor's SUF, or subsídio único familiar participation, 1 year from now, on my distance to the cutoff, you get a graphical representation like this, where I again have a jump of about 0.02. And if I'm thinking about how my participation in SUF affects the participation in SUF of my neighbor, I need to divide this coefficient here, how my eligibility to Chile Solidario affects my neighbor's SUF, by the reduced form in the previous paper by Pedro, Rita, and Emanuela, which is 0.04. So this will give me an, back of the envelope estimate for beta, which is about 0.44, which is pretty high and not far from what we get in our preliminary calculations. Now, if you try to look at placebos, I try to look at the effect of my distance to the cutoff on a neighbor that was already in SUF before Chile Solidario was implemented, you see nothing. If I try to look at my distance to the cutoff on a rich neighbor's SUF, on whether a rich quote unquote neighbor takes up SUF, I see nothing, as you would expect. So again, this is also reassuring. Now, these are the pies for building sizes. So on the leftmost columns, you will see the quote unquote reduced form coefficients for my own CS pi, the pi 1 that was I alluding to before. And on the rightmost columns, you will see the pies for the neighbor CS, the pi 2s. And we do that for our whole sample, and also restrict the sample to areas with high density to see if we have any difference. But for most of the part, I'm focusing on all of the sample here. And as you can see, the pi 1, as I told you, is going down, 0.29, 0.22, 0.010, 0.02, and the pi 2 is going up, 0.02, 0.010, 0.20. It goes down in the end, but at least in the beginning, it's going up. If you look at individual significance, you get a lot of imprecision, but remember, what I'm interested in is not the pi ultimately, it's the beta and the lambda, okay? So what I'm interested in is the significance of beta and lambda. So if I do the Chamberlain procedure that I referred to before to get the beta and lambda from these pies, what I get is a beta of 0.5, 0.6. Again, not super far from my back of the envelope calculation of 0.44. And the lambda, the direct effect of the social worker in Chile Solidario on the individual taking up SUF of about 0.2. Remember that if I didn't factor in the spillovers, I would get 0.27. So the direct effect goes down by 30%, a third. So it's substantive. And no matter how you cut the data, you will get, perhaps sometimes more instability and imprecision on how you calculate the beta, but the lambda invariably turns out about 0.2, which gives us, again, confidence that this result is not spurious. So for instance, if I do the disco jam using SUF on the right-hand side instead of Chile Solidario, I get an imprecisely calculated beta, but then again, the lambda is about 0.2, slightly above. Again, looking at the high density areas, I get more precision in the beta, but a lambda of still about 0.2. If I look at the same sample that Brita, Pedro, and Emanuela were looking at, I get 0.2. I think I'm probably wrapping up.
You have 5 minutes already.
Oh, I'm very close to the end. Really very close to the end. This is essentially my second to last slide. Now, the types of things that we're starting to do now is to look at heterogeneity, and we are looking at, again, proxies for cost of compliance, cost of application, and proxies for awareness. So if we look at proximity to school, the Chile Solidario appears to be less effective far from schools. Again, it's harder to comply for these families, especially for the kids that are between 13 and 18 years old. The cost to sign up doesn't seem to change much. One thing that, resonates with the survey that I shown before is that if I look at individuals that had no subsídio único familiar before the implementation of Chile Solidario, I get essentially the same results that I had before, a lambda around 0.2, precisely estimated, and a beta of about 0.5. But if I look at neighbors that had subsídio único familiar before 2003, so these people at the very least were aware of the program, I see nothing. I mean, the lambda is essentially 0, and if the lambda is 0, I have no hope of recovering beta. Okay, so again, this gives us a clue that what's going on has to do with awareness. This is essentially my last slide, but let me tell you one thing before, give me 30 seconds. There is one thing that is somewhat inadequate in what we're doing. We have a binary outcome and a linear model, and it's perfectly fine and recommendable that you run your linear probability model when you have data. But when you have a system of simultaneous equations, things get a little bit more complicated because you don't have unique solutions to that. So one of the things that we're hoping to address in the next few months is to deal with nonlinearities. And this relates to the econometric literature looking at games in empirical I/O, where individuals or researchers are looking at whether a firm enters a market or not. So they're going to play a Nash equilibrium in this very simplified 2x2 game here. I enter 1, I don't enter 0, and if I enter, I get a payoff that depends on x's and epsilons. In I/O, the lambda is typically negative. More firms in the market are less profitable. And the Nash equilibrium for this will deliver in the space of unobservables for the game the following situation. If the market is sufficiently profitable, both firms will enter. If it's sufficiently unprofitable, none of the firms will enter. But there will be circumstances in which the firm or the market is only large enough for one firm, and there will be possibly multiple equilibria. In our case, this lambda is not negative. A large market, I mean, more people in the market making it less profitable, but it's plausibly positive. More people taking up CS will induce me to take up CS. So we're going to have a slightly different game, and our hope is to do not only the GMM at a discontinuity, but now estimate a game, a cooperation game around the cutoff at a discontinuity. And with that, I'm going to conclude because I already took too much of your attention. Obrigado.
Okay, thank you, Áureo. Great. So I'm now open to questions. So, Bruno.
Okay, thank you. Thank you, Áureo, for the great presentation. Actually, I think my question is probably not that specific to your setting, but when you have like that econometrics model, we essentially are assuming like the steady state equilibrium of this game between of these interactions between the players. Have you thought a little bit about the dynamics, whether it might take a little bit of time until people react to what their neighbors are getting, and whether the timing that you're analyzing will take that into account?
Yeah. Yes. Thank you, Bruno, for your question. Is a great point, and is a point that we did think a bit about. This is partly the reason why we are looking at SUF 1 year after the take-up of Chile Solidario. But if you think about the contemporaneous or, the timing at which I take up SUF and this translates into my neighbor taking up the program, or vice versa, of course, this doesn't necessarily, for me to be able to represent this in this game, it doesn't need to necessarily be done at the same time. It just needs to be done more or less with the same information set, right? Ideally, I agree with you. It would be great for us to look at the dynamics to see, who takes up first and how does this percolate in the building or through Santiago. And we have been thinking about some strategies in that respect. One difficulty in doing that is as I said, the data is great, but it's not perfect. We only have coarse observations on the timing. So we only have a coarse observation on when people take up. We only see it at the yearly level. We could try and leverage even this coarse observation to see if we have richer dynamics than the very simple setting that I'm offering here. We are thinking about alternatives, but we haven't yet settled on something that, to me, provides a sufficient bang for the buck in terms of making the model more complex and giving me greater insight. But that's something that definitely you would like to look into here. Again, one can also probably go to the dynamic games literature if I'm thinking about a game. And this is something that we've also been contemplating, but we haven't really done anything yet on it.
Thank you.
Any other questions?
I said, Áureo, just a quick question, a very nice talk. So if I understood correctly, you're kind of narrowing down on the awareness channel because of that final result where you didn't find much for people who actually were aware of the program before, a couple of years before, right? If I understood it correctly.
Yeah.
So my question, were those people who were aware of the program and were not signed up? Because if they were already signed up, you wouldn't expect much effect anyway, right? So do you see my point?
Yeah, no, I see your point. These people, they participated in, so what happens is this program lasts for 3 years, by the way. And then it's not like you can't participate anymore. You can re-enlist if you are still eligible. And we look at people that participated before 2003, but it is true that we are not looking at these people at the moment in which they are, prompted to participate again. So we probably can cut the data in ways that would be perhaps more satisfactory in that respect. And that's a good point. We are not doing anything like that as of now. Now,
the thing that had crossed my mind, if these people already expect to have a high sign-up rate, so you wouldn't have much of a response. I was thinking about other spillover channels actually related to some stories that you articulated during the talk, right? That maybe when there's more people in your building that are signing up, that you have the social worker walking around and so on, and you just bump into him, right? So it's a spillover that wouldn't be really a peer effect, right? So it'd be like a technological spillover, I guess, something like that.
Yeah, no, so that's well taken. So here's the story. So one of the things that we hope to do, and we are experimenting with it, is to get at the social worker story, is to not only control for my Chile Solidario, but also for the Chile Solidario of my neighbors. Because that will essentially capture, one part of what you're saying, which is, my neighbor might have received the social workers, even if this person was not eligible for Subsídio Único Familiar, he would have given me my information about the program. Or this may also encode the fact that I bumped into the social worker that went to visit my neighbor then. So this is one thing that we hope to look at. And we have done some explorations. It lowers a bit the beta to about 0.3. The gamma is positive, so my neighbor receiving Chile Solidario does affect my take-up of SUF. But you know, it doesn't change the lambda by a huge amount, to be honest. Now, the other thing that you were alluding to is has to do, and at least that's how I think about it, about how could we probably capture some of these other explanations that people refer to, like stigma. So there are a couple of ways in which we are hoping to look at that. One is to, and I'm not sure how feasible that is going to be in the data, which is to look at your ranking in the building. So if I'm in a building where everybody is quote unquote richer than me, am I more or less inclined to take up if nobody else does? If I live in a building where I'm richer than everybody else, but still eligible, how does that affect my take-up behavior or not? And the game itself may give us a window into the stigma stuff, because the stigma is the type of thing that will translate into either everybody in the building takes up the program or nobody in the building takes up the program. Of course, you know, these are extreme cases, but you know, it translates into you having this clustering in terms of take-up behavior. So the game will help us in that respect. We'll introduce these non-linearities that a simple model like the one that we have wouldn't be able to capture, because it's too linear, unfortunately.
Thank you. Thank you.
Thank you, Rodrigo.
Okay. Okay, so any other questions? Okay, so it's already 2:30, and thank you, Áureo, for this brilliant presentation and for the very nice paper that you gave to us.
Thank you very much, Sergio.
Okay, okay. So everyone is clapping virtually, so let's see if I know how to do this.
Well, thank you all for coming. And please do let me know should you have any further questions that haven't arisen during the talk.
Maravilhoso, obrigado, cara.
Obrigado, Sérgio. Bom revê-lo. Agora eu vou para a sessão do Bruno.
Vamos lá, valeu, gente.
Um abraço.
Valeu pela propaganda, Áureo. Na verdade, tem 2 sessões com paper meu, então tem que escolher.
Opa, tem que... A gente leitoriza, vamos leitorizar aqui.
Exatamente, eu vou jogar os dados aqui. Obrigado, Bruno. Te vejo daqui
Valeu,
a pouco.
gente. Até mais, obrigado.
Valeu, gente.